Okay, in this video I'm going to show you how to solve quadratic equations that are in disguise. Yeah, they're in disguise because they don't look like, they kind of look like quadratic equations, but they're not necessarily apparent that they're quadratic equations, right? Like, for example, what do you know about quadratic equations? Well, we know the standard form. You almost always want to compare whatever problem you get, by the way, when you do quadratics. You always want to compare the information you get to the standard equation or to the standard form of the equation, okay? And remember the standard equation, standard form is ax squared plus bx plus c is equal to y. And when you solve for it, you make the y as 0. So try to get this information into this form. And you'll notice that it's pretty close already, isn't it? What are some of the differences? Well, let's see. Well, I know that, for example, it's supposed to be squared, and here I have a 1/3. It's supposed to be something times x to the first, and this is x to the 1/6. You know, the minuses and the plus, not a big deal. I can just go add the opposite, and I'll get pluses there. So really, the main issue here is these guys here. It's the x to the 1/3 and the x to the 1/6. So what could I do? What could I do? Well, there's this little test that has been developed that helps you to look past the disguised quadratic to see whether it's a real one or not. And this is what the test is. You take that term right there. You take the linear term. Remember, this is called the linear term. I don't know why I did that. Linear term. Oops. Let's get that going there. So you take the linear term and call it something else. I like, there's a Greek letter that we use called mu, it's mu. And you just make the linear term equal to mu, okay? So x to the 1/6. And then the test is to square mu, which means you square x to the 1/6, or whatever the linear term is in your problem. And once you square that, got to remember your exponent rules. When you raise an exponent to an exponent, you multiply. So that's the same thing as saying x to the 2/6, which is just x to the 1/3. Does that sound familiar? X to the 1/3 is your initial term. So really what you do have is a disguised quadratic. Now what I want, you have to see if these match up. If you do match up, then you've got a disguised quadratic. Now take this original problem and rewrite it using the mu's. I know it sounds kind of funny, but let's do it. So x to the 1/3 is mu squared minus x to the 1/6 is just mu minus 6 is equal to 0. Now it looks a lot easier to see whether this is a quadratic or not. And you know that it is, don't you? Matter of fact, it's a quadratic that I can actually solve by factoring, can't I? By the way, if you couldn't factor this, you can go ahead and use the quadratic formula. You could use completing the square. There's a lot of ways to solve this particular problem. In this particular one, though, it's easy enough to solve by factoring. I get mu minus 3 and then mu plus 2 is equal to 0. Because remember, negative 3 times positive 2 is negative 6, but negative 3 plus positive 2 is a negative 1. And that's how you do that. So in my next step, again, I'm saying that mu minus 3 is 0, or mu plus 2 is 0. Because remember, this is called the multiplicative, the zero property of multiplication, sorry. The zero property of multiplication. And that's zero property says that in order to equal 0, one of these two factors has to be 0. So do we know which one it is? We don't. So let's say that the mu minus 3 is 0, or then we'll do another case where the mu plus 2 is 0. That tells me that mu is either equal to 3 or mu is equal to a negative 2. That's not quite the answer, though, is it? Because now what you do is you go back and substitute and solve for the x. Because mu is really just x to the 1/6. So make sure you do a substitution here. Or mu, x to the 1/6, is equal to a -2. Okay, now how does that help us? Okay, again, you need to go back and remember how you simplify fractional exponents. Okay, how do I make this equal to a whole number? What could I do to it? Well, I could raise it to the 6th power. Why 6? Because 1/6 times 6 is equal to 6/6, or 1. So now that gives me x to the 1st. But if I raise this to the 6th, I have to raise this to the 6th as well. Okay? So x is equal to 3 to the 6th power. Now what is actually 3 to the 6th power? Let me grab my calculator real quickly. 3 to the 6th power is, let me see, 3 times 3 to 5, 6, and that gives me 729. Now you do the same thing onto this side. I'll say x to the 1/6 power raised to the 6th, or -2 raised to the 6th. That's going to give me x to the 6/6, or 1, is equal to -2 to the 6th power. Now I know when I raise a number to the even exponent, it's going to turn out to be positive, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So -2 to the 6th power is 64. Probably a good idea to check this just to make sure they both work. Okay, so let's go back up and put in x is 792. We know that 3 to the 6th raised to the 1/3 power minus 3 to the 6th raised to the 1/6 power minus 6 is 0. That's just putting in 729. Let me just check this. Raised to that power is going to be 6 over 3, or 2. 3 squared, or 9. This is going to be 6 to the 1/6 is 1, so minus 3 to the 1st, or 3, minus 6 is equal to 0. And sure enough, it is. So this one works perfectly. Okay? Now let's check the 64. We know that -2 to the 6th, that's my x. Raise it to the 1/3, because that's the original problem. Okay? Minus -2 to the 6th raised to the 1/6, and then minus 6 is equal to 0. Let's see if this one works. 6 to the 1/3 is 2. -2 squared is 4. Minus 6 to the 1/6 is 1, minus a -2. Okay, and then minus 6 is 0. 4 minus negative is like saying plus 6. Excuse me, 4 plus 2, rather. Sorry. 4 plus 2 is 6, and then minus 6 is 0. So this one works as well. Both your answers work. Okay, so again, briefly, what do? You go up to and do this mu test. I call it the mu test. Do you have to use mu? Absolutely not. You can use any letter you want. You can use a box, you can use a tree, you can use a cat. Just something is equal to the linear term, okay? Then you square it, so square your mu, and if you end up with the first term or the quadratic term in your problem, you've got a disguised quadratic. Then you go ahead and either factor it, you can go ahead and complete the square using the mu, or you can put it into the quadratic formula. All of those will still work. I just happen to be able to factor it. So I factored it. Once you got to the mu is equal to some number, go back and substitute what the mu is. Okay, change that back, and then go ahead and solve it from there. Remember, if you have fractional exponents, remember how to raise it. And then make sure you check at the very, very end. Okay, I hope that was helpful.